This is 5.3. This is the second part of it. So we're actually solving equations now. Wow. Here we go. So undoing the things being done to n. So we're going to add 5 to undo subtracting 5. So we get n squared equals 36. So to undo squaring, we square root, which really means what number times itself equals 36. So the answer is positive 6 and negative 6, because negative 6 times negative 6 is 36. If you plug negative 6 in here and you square it, make sure you put parentheses around it, and then subtract 5, you would get 31. Same with if you put a positive 6 in. Here we go. Let's undo multiplication first. By the way, folks, when you are undoing this thing, if you're like, should I square root first or should I blah, blah, blah first? Remember, you undo addition and subtraction first, then you undo multiplication and division next. Lastly, you kind of undo exponents. However, if there's something being done to x in the parentheses, like here subtracting 2 in the problem that I made up, subtracting 2 is actually the last thing you would undo. So you undo the order of operations backwards, or in the exact opposite order that you would do to simplify. So here we get 9, negative 9, I want to say. Oh, just kidding, we're divided by negative 5. So we get 9. Yes, we definitely get 9. So then that's what x squared equals. So we're asking ourselves what number squared equals 9. So it is positive and negative 3. If you plug negative 3 in here and then square it and then multiply by 5, it would equal negative 5, it would equal negative 225. All right, so we're going to undo addition and subtraction first. So we get 6b squared equals 24. Undo multiplication next. We get b squared equals 4. Undo squaring by square rooting. And b equals whatever times itself is 4, which is positive and negative 2. That was a bad looking 2. Naughty. 2. Number 4, let's subtract 2. So we get 8a squared equals 392. Dividing by 8. So we get a squared equals, so I know that 8 times 50 is 400. Whoa, because 8 times 5 is 40, so add a 0, it's 50. And I know that this is 1/8 shy of that. So 1/8 shy of 50, or 1 shy of 50 is 49. That's what a squared equals. So now we need to square root. So we get a equals positive and negative 7. That was fun. Add 10. Add 10. 8x squared equals 192. Divide by 8. Divide by 8. You get x squared equals, let's see, 20 is 160, so I think that'd be 24. So now you get x equals the square root of 24. But that's really the plus or minus. So x equals whatever the square root of 24 is, positive and negative. But then we need to break that down. Break it down now. Can we get a more exact answer or a simplified answer? 4, square root of 4 times the square root of 6 is equivalent to that. So the best answer is plus or minus 2 roots of 6. That's fun. Next one. We'll add 3 to undo adding a negative 3. So we get 16x squared equals 81. Now we divide by 16. So then we square root that. So x squared equals the square root of, the square root of x squared equals the square root of 81 over 16. But remember, we can take that and change that into the square root of 81 divided by the square root of 16. And I forgot when I square rooted. Remember, that's going to give us a positive and negative answer. And when we simplify this one, the square root of 81 is 9, and the square root of 16 is 4. So that's plus or minus 9 roots of 4. All right, last couple here. Here we need to, so remember our order of operations. There's no addition or subtraction outside of the parentheses. When you say x is getting subtracted by 3, it's within the parentheses. So it's actually the last thing we're going to undo. There's no multiplication or division to undo, but there is this exponent to undo. So the first thing we're going to actually undo here is to undo the squaring by square rooting. And when we square root, that gets a plus or minus. So we get x minus 3, because I've undone squaring by square rooting, plus or minus the square root of 20. But remember, the square root of 20 is the same as the square root of 4 times the square root of 5, which is equivalent to plus or minus the square root of 2, plus or minus 2 times the square root of 5. So last thing to undo here, I've undone that now. Last thing to undo is subtracting 3 in the parentheses by adding 3. Now when I add 3 to the left side, I'm adding 3 to the positive value of this and to the negative value of this. So we're going to say that x equals a positive 3. The 3 is definitely positive. But what changes is whether or not the 2 square roots of 5 is positive or negative, because that gives us 2 different answers. So there is our final answer. You put this number that you know is positive in front, and then both of these count, so you put that afterwards with the plus or minus. The plus or minus is the symbol or the signs of that 2 roots of 5. So here, let me move this stuff out of the way. Move. Oh, I can't move. That's mean. All right. So let's redraw this. What's being done to x? Outside of the parentheses, it's getting subtracted by 7. It's also getting multiplied by 2. It's also getting squared. And it's also getting added to by 1 in the parentheses. So I'm going to undo subtracting 7 first by adding 7. So I get 2 times x plus 1 quantity squared equals 32. Next, I'm going to undo multiplication or division by dividing by 2. So I get x plus 1 squared equals 16. Next, I'm going to undo squaring by square rooting. So I get x plus 1 equals the square root of 16, which is plus or minus 4. I should put a plus or minus in front of every square root that I do to remind myself that it's a positive and a negative answer. Then from here, folks, I subtract 1. So my answer is x equals a negative 1. This 1 is definitely negative. But what's waffling is, or what gives me my 2 answers, is the 4 could be positive or the 4 could be negative. So I'm going to take this and rewrite it with a plus sign. So negative 1 plus 4. And I'm going to also take it and write it with a negative sign. Negative 1 minus 4. And that's going to give me 2 exact answers. So x equals, this one gives me 3. This one gives me negative 5. Beautiful, beautiful, beautiful.